Hello students, let us go through some more sums based on when there are variables in the denominator, right. This time the sum is 7 upon 2x plus 1 plus 13 upon y plus 2 is equal to 27 and 13 upon 2x plus 1 plus 7 upon y plus 2 is equal to 33. Now the difference in this sum is in the denominator, initially whatever sums we saw, the denominator was either x, and y. There was only a monomial, a single term in the denominator, single variable in the denominator. But in this sum, there is a binomial term in the denominator, 2x plus 1, 2x plus 1, y plus 2, y plus 2, right. But nothing to worry, we will stick to our concepts. Whenever there are variables in the denominator, we need to go for substitution, right. So let's do that. The equations given are 7 upon 2x plus 1 plus 13 upon y plus 2 is equal to 27 and 13 upon 2x plus 1 plus 7 upon y plus 2 is equal to 33. Let's take the first equation. We can write this equation as 7 into 1 upon 2x plus 1 plus 13 into 1 upon y plus 2 is equal to 27. And the second equation is 13 into 1 upon 2x plus 1 and 7 into 1 upon y plus 2. It's very, very easy. We can see that 1 upon 2x plus 1 and 1 upon y plus 2 is common. So we need to substitute 1 upon 2x plus 1 as m and 1 upon y plus 2 as n. So don't be worried about a binomial term in the denominator. The method remains the same, right. Let's do the substitution now. Let's do the substitution in the first equation. So you get 7 in place of 1 upon 2x plus 1 we write m. So you get 7m plus 13n is equal to 27. Let this be the third equation. 13m plus 7n is equal to 33. Let this be the fourth equation. Now we are getting the third and the fourth equation, the simple two equations which we can easily solve. How do we solve such equations? You can see the coefficients are diagonally same, right. You can see this 7, 7, 13, 13, the coefficients are diagonally same. So we can go for the ASA method. ASA method, the first step is adding the two equations. So let us add equation number 3 and 4. That's your third equation. That's your fourth equation. Let's add. 7 plus 13 is 20. 13 plus 7 is 20. ASA, after adding or subtracting, the coefficient of m should be same as the coefficient of n, right? And 27 plus 33 is 60. 20m 20n is equal to 60. The next step is dividing throughout by 20, right. So what we get is m plus n is equal to 60 upon 20, which is 3, and we get our fifth equation, that is m plus n is equal to 3. Are done with the addition step. Now the next step is subtraction. So let's subtract equation number 3 from equation number 4. First write the fourth equation, then write the third equation, and don't forget to change the signs. Plus 7m becomes minus, plus 13n becomes minus 13n, and plus 27 becomes minus 27. So what we get is 6m, 7 minus 13, so it's minus 6n is equal to 6. 6, 6, let's divide throughout by 6. We get m minus n is equal to 6 upon 6, which is 1. Let this be the sixth equation. Addition done, subtraction done, it's time for addition again, but this time it's adding equation 5 and 6. So that's your fifth equation, that's your sixth equation. Let's add. M plus m will become 2m, n is already cancelled, 3 plus 1 is 4, 2m is equal to 4, you get m is equal to 4 upon 2, that's m is equal to 2. Once you get the value of m as 2, now it's time for us to find the value of n, and for that you need to substitute this value of m either in the fifth or the sixth equation. Fifth is preferable because there's a plus sign, but you can substitute in sixth as well. The choice is yours. Substituting m is equal to 2 in equation 5, we get 2 plus n is equal to 3. You get n is equal to 3 minus 2. You get n is equal to 1. You get the value of m, you get the value of n, but the sum is not over because wherever there is a substitution, there has to be a resubstitution. So let's resubstitute the values of m and n, right? M we had substituted as 1 upon 2x plus 1. Now we got the value of m as 2. So can we say 1 upon 2x plus 1, in the place of m we can write 2. So it's 1 upon 2x plus 1 is equal to 2. And similarly 1 upon y plus 2, In the place of n, we can write 1. So, 1 upon y plus 2 is equal to 1. Now, invertendo, so we get 2x plus 1 is equal to 2 becomes 1 upon 2. Is this invertendo step clear? Similarly, 1 upon y plus 2 will become y plus 2 and 1 invertendo is also 1, right. Now, let us solve the 2. Now, to solve this we can cross multiply, right. You can take this 2 to 2x plus 1, you can multiply 2 to 2x plus 1, cross multiplication. So, let us do that. What do we get? 2 2s are 4, 4x, 2 into 1 is 2, that is cross multiplication is equal to 1. And here y plus 2 is 1, so y is equal to 1 minus 2, right. Now, solve this part. Let us do it. 4x is equal to 1 minus 2, variables on one side, constants on the other side, and we get the value of y as minus 1, right. So, 4x is equal to minus 1, y we have already got as minus 1. So, x is equal to minus 1 upon 4 and y is equal to minus 1. So, the final answer is solution is x comma y, that is minus 1 upon 4 comma minus 1, as simple as that.